Welcome to Module 16 of a course called Coding for Crosswords. In this module, we will code the solver. We're not going to finish it, but we'll start and we'll see how the pieces of how we've been working with the library, the grid, and the other helper routines and helper objects will all come together and let us construct the puzzle. For a reminder of the problem that we're solving, it is to take this initial seed, like this puzzle, for example, with the dog and the cat already filled in, and to have the program look at all of the unfilled answers and try every single word that might fit in here. So it might write in data. It might look at the next word and it might say, let's do ogre here. And then it might do age. And then it might do Tron for the movie. Not sure if that's in the top 12,000 English words, but you get the idea. AE is probably get limited. So once it tries to commit those words, so far it might hit a point when it says, nope, I can't do it anymore. And in that case, what we do is we just back up, take that word out. Maybe we take out Tron and we write in a different word in there instead. You know, we write in tree. So the process of having the computer solve a puzzle like this, and by solve, again, I mean constructing the puzzle. We're not really solving the puzzle by reading human clues and trying to decipher them. We're just constructing the crossword puzzle. So that's what I mean by solve and by a solver. But the process of solving this puzzle is iterative. It's recursive. We have to dive in multiple times and try different words, and it has to back up. It has to try things, see if they work, and if they don't work, and most of the time they won't work, it will back up. And it will find occasionally, in its thousands and millions of attempts, it will find one of the solutions that will work, and then we can print that solution out. So let's review where we were in the last module by looking at the source code. Let's go to the very bottom of the file, and we're going to see that we are starting to get enough code in here that the Spidey sense should start to say this belongs somewhere. We don't really want a lot of code in main. What we really want is a new class, and let's just make that class now. And let's call it a solver. Solver. Okay, so let's put the template in. Let's leave main out here on its own. We would like to have solver be the class that's responsible for really doing all the work. And so when we construct a solver, remember this is the constructor, it's the function inside the class that has the same name as the class name. What do we want to do when we construct the grid? Well, I think a good way to do it is to give it the grid. And let's give it a pointer to the grid because we want the grid to be living and owned by somewhere else like main. So this will not take ownership of the grid. This will not delete the grid. It will just take a pointer. You could also do this as a reference, but it gets a little trickier in some cases. So I'm going to do a pointer here. And that means that as part of private data, it has to have a grid pointer like this. And we're going to initialize that like you've seen before. When we create the solver, we're going to take a copy of that pointer to the grid. Now, it's not a const grid because we are going to modify it. You could write it with a const grid where you would make a copy of it internally to the solver, but we're going to go ahead and let it be a non-const pointer to grid here. So this is going to look a little different. We're going to build the grid, load it, we can check it, we can even print it. We can fill the spans and print them, although we're probably going to not print them. That's like a little bit too much noise. And then we're going to have a solver. And we're going to give it the grid. For this library, I'm going to do something here that's not that great. People could criticize it, but I think for this application, it's actually not bad. I'm going to make the library a global. And globals in general are kind of controversial. You don't really want them. One of the issues with globals is that the order of the constructors is arbitrary. You can't guarantee that one global will be constructed before another global. So if you have too many globals and they depend on each other in a complicated way, that's bad. But one very simple global like this is really not the end of the world. And so I'm going to put it at the end of the library class. I'm going to define the library class, and then I'm just going to put this global here. That means this lib will be accessible through the whole program. The other way to do it would be to pass the lib around. You could have a pointer to the lib that every class, the solver would get a pointer to it, and then when it calls things in the grid, it could take a pointer to it. That's just a lot of extra passing around of the lib. And we know for this application, we only want one library. So really, it's not the end of the world to put the library here. And we don't actually even do anything in the library constructor right now, so there's no real issue with the order of constructors. So I'm going to go ahead and do that. And what that matters down here is that then we can just. So here's all the stuff with the grid. Then we can do the thing with the library. We can read the library from file. And remember, when we do that, we're creating this pattern hash table. Go back to the previous module to read about that if you like. We're reading from this file for the 12,000 most popular English words, and then we're going to pass into it this 7 probably, or whatever the grid. You could change the grid file and it'll pass a different number in. And that's going to be the hint to the library reader to only care about words that are that size or less, because the grid won't be able to put any larger words into it. It's not going to be able to fit them. So that helps us speed up the library parsing, which is good. So then we're going to head and call the solver, and then we're going to put most of the rest of the work up here. Well, sorry, that creates a solver. Then let's create a routine called maybe solve. That's probably fine for now. So when you create the solver, it does nothing. And then we're going to have a separate routine solve. It's general style not to put too much work in the constructor. You could actually put all of the whole rest of the function we're going to build and the rest of this module and the next we can put into the constructor. But in general, you don't want to do too much in the constructor. It's a good style just to have the constructor do just the things necessary to build a complete consistent object, and then put any actions like solve the grid into a separate functions like this. So that's going to be a public function. And in here, we're going to first look at the spans that we created. So look at this print spans that we had here. We looped over the spans, right? So I'll go back to the solver here. This is going to be kind of a handy construct. What we're going to do in the solver is build a loop. In fact, let me just go ahead and do that now. We're going to have a private function called loop. Okay, the solver, well, let's say something like constructing, or I can just use the word solving this grid. And let me put that grid print stuff, put that print in here. It kind of makes, I think that makes sense. Solving this grid. And now grid at this level, remember grid is a pointer now. We've named it grid underscore for one thing, and then it's also a pointer. So we're going to print the grid, and then the spans are going to come from not just spans anymore, but grids spans. Remember, we use this little arrow now because we've used a pointer to a grid. It's really using this thing at this point. So we're going to print the grid, and then we're going to go over all of its spans. And what we want to do is, actually, I was going to put this into the loop. I'm already thinking ahead because the solve routine is going to call loop, and we're going to do something that's called a recursion. We really need to do some work to write a word into the grid, and we know we're going to have to do that more than once. So rather than having a loop to do that, there's a neat idea in computing called recursion when you can just have the loop function. This will go ahead and do some work to find out what spans are in the grid, and then somewhere in here we're going to do what's called committing. We're going to commit the slot. And then call loop again, which is going to come back here and take the same grid and call loop again. So I'm preparing the case for this loop function to do most of the work of checking what the grid looks like now, finding some spans to work on, asking the library what words will fit in there, committing one of them, and then calling the loop again. So that's the basic idea of the module today. We'll see how many of those steps we get done in this module and how many we'll have to spill over to the next modules. But let's at least start this. So here we go. Let's stop at this point and just see if we compile this. This should just compile now, make sure that we're on good grounds. And again, that's always our normal command, a.c. And we've already got some errors, so let's see what those are. So 351, no matching call to solver grid. That is because, back up here, I declared this stuff private. I forgot that a class by default starts with everything private. So you have to say that these routines, the constructor and then this routine, are public so that the code down here in main can access them. That's important. Actually, the code is a little further. This code here can access them. Right. So let's go ahead and see if that fixed those errors. And there's still one error. Line 352. Let's see where that is. 352. No matching function call to solver grid. Yes, because we're passing, it's expecting a pointer to a grid, and we're passing in the actual grid. So that would work if it had been a reference we had used. And if this is confusing, there's objects that you can pass by value, and then there's references to them, and then there's pointers to them. And those concepts are fundamental, and there's an earlier module that really discusses all that in detail. So the operator for getting the address of in C++ is this ampersand sign. So we really need to create the solver with an address, a pointer to this grid object, which lives up here on the stack. So the grid lives on the stack in main. When we call into solver, that just stays there. The stack just grows down, and the solver will have a pointer back up to the grid object in the stack, which will be alive the whole time that solver is being called. So that's fine, because the lifetime of the grid is the same as these braces, right? So when you create something in C++, the lifetime of every object is scoped to this scope defined by these braces. And so grid will be alive the entire time that our solver is alive, including the constructor and the solver. So that's good enough. So that should solve the compile error. And then it does. And then when we run it, it just says, reading the file, that's fine. And then solving this grid. And then we print it, and it's a my grid. That's just what we named it up here. And then we say it's 7 big. And then here's the grid itself, and that's it. So now the fun part begins. Let's start to talk about what types of spans we have. We need a helper class. And the helper class is going to be called, I'm going to call it a slot. It's like a span, only it's a little bit more. It's like a span with a little bit more information about the work that has to be done there. And I'm going to make it a plain old data structure. So it's just going to be a simple struct. It doesn't have to have a lot of secret stuff inside it to make it a class. I'm going to just lay it out there. It's going to just be a simple, obvious public struct. So here it is, slot, with the normal stuff we do. When we construct it, we're going to probably want to construct it with a span. And I think we'll just copy a span in, since spans are easy to copy. They're also simple data. And let's have a span here, span. Okay, so the slot has to know, first of all, what span it's part of. Should it know what grid it belongs to? I think we can leave that off for now. We kind of know, the solver knows it's working on a grid. I don't think we need to have the slot itself know what grid it belongs to, unless we start asking the slot questions that it has to go look at the grid itself. But I think for now, we're going to keep the slot a simpler data structure where any of those type of questions we're going to have to do at the next level up when we call the slot. We're not going to have the slot be too smart. It's going to kind of be a little bit of a dumber object. So we're going to leave it, actually we can leave it just like that for now. And we want to have a vector of them. And since it's just a simple data object, we don't need a vector of pointers to them. We don't need to guarantee that every slot is unique. We can just have slots be copied. If the vector needs to expand and grow, it can copy the slot. That's okay. So we're going to say a vector of slot, we're going to define just this type to be slots. And again, those type def, some people like them, some people don't. It's fine. You can also just put this vector slot everywhere you want to. Everywhere you see me use slots, you can just type in this whole thing, and that's the same idea. This type def is purely just a shorthand. It's just saying, call this thing a slots. Okay. I just find that easy to read the code then when you have like the plural, when this plural s is for the collection of things. Then we can later change that to a list if we want very easily, or a double-ended queue, or other sorts of data structures that have different properties if we need to change it. But for now, it's going to be a vector. That's the simplest one to use. You should always use that first before you need any other capabilities. So what are we doing with this? So we want to, in the loop, here's the thing. Here's my proposal. There's different kinds of spans. There are some spans that have all the letters already done, like the dog and the cat. And there are some spans that have nothing done. They're totally blank. And there are other spans that have one or more letters filled in, but other letters are blank. And those are three categories of spans that are it's useful for us to understand how those are different. So let's make a list of slots. Let's call one full spans. Let's call another one, I'm going to call it maybe partial. To do would be one way I was going to name it to do, but partial is probably a little more accurate. Empty. Okay, so these are the ones we want to work on, right? How do we know for a given span which one of those three it is? Well, let's first get the string. So we want, here's the string. Let's call it temp, maybe that's fine. Temp is going to equal what? There's this routine we wrote before, and if you haven't seen this, go back to the previous module called getString, and we give it the span. Okay, let's make sure that is correct. There's our getString backup, and this is back up in the, I just searched back up here. Sorry if that was too quick. This is the grid class, okay? So getString is right here, and we wrote that last time, and what it does is it takes a span, which is just a description of a series of boxes in the grid, and it loads the characters from those boxes, it writes them into a temporary string and returns it. So, so that's here. So what we're going to do is we're going to grab that string. Now we could do something here. We could start to analyze that string. We could write code in here that would say for int I equals 0, I less than temp length I plus plus. And this is going to go over every character of temp, right? We could check in here if the character of temp, you know, is a blank, blank like that, you know, then categorize it into one of these three things. So that's one way that's possible, and I just show it there because that's a reasonable way to do it. There's actually a better way, I know from coding this before. There's a way that is a little nicer, and what that is to do that, we have to take a little bit of a detour back up to the get string. Let's suppose we have another little helper class, and I really like using little helper classes like this because they almost always add to the understanding of the code. You know, maybe a little extra typing, but they sort of self-document what you're trying to do with things and what you think is important. And the thing that I want to do here is an attribute. A class called attribute or a struct called attribute. And what it is going to be is simply this. It's going to be attribute, and it's going to have just two things in it. It's going to say has letters, okay? And it's going to say has blanks. And the whole point of this is just to record for a given span what characteristics it has. And here's how we're going to use this. So that's really it. And then we should probably have these be false by default in the initializer, right? So it's a very simple struct. I don't even think we need a constructor for it because these initializers will be good enough. Those initializers will always kick in and keep this thing false. So we could just make up an attribute whenever we want and then just turn on which of these bits we want. And here's how that's going to work. I'm going to change the get string to return one of these attributes. Now we've already used the return for the string, and functions can only return one thing. Now it's true, we could make a complex data type to return this. We could have it return, there's a thing called a standard template library pair, an STL pair. We could have it return a string and that attribute, but that gets kind of complicated. So an easier design pattern is just to say this is the input, but what the output is going to be it's going to also require another argument that's going to be the attributes. So when you call getString, it's going to always fill in this attributes. So we can even say that here. Fills in attributes, of the string. So now let's do the work of filling in this attribute. So remember, we just defined this attribute here, and it has two things we're trying to track with every string. Does it have some letters filled in, and does it have some blanks? And what we want to do is discover that information while we're getting the string. We're looking over every single character right here already. You know, it's a great chance to go ahead and look at those characters and see, are any of them letters? Are any of them blanks? So that's a good challenge. Try to write the code right in here that will do something to categorize the character that's coming out of box, and then set this attribute field the right way. Okay, give that a try, and I'll give you a hint in a second. And here's the hint. The hint is we can save this box P. Let's put it like this instead of assigning it right away to the output string. Let's save it, and we're going to wait on that just a little bit. We're probably going to assign C to it, but let's look at what C is here. Now, if C is something, okay, so this is your hint. You're going to do something. Else, if C is something else, you're going to want to do something else. So that's your hint. See if that gives you enough to go on. And the thing you're going to be doing inside here is setting something with attribute, right? And so if you're back, here's what it is. If C is a blank, and remember a blank in the way we're coding things is this dash. It's not a space. We're not using a space. We're using a dash in our input file. So whenever there's an empty square in the grid that is not yet committed with a letter, we haven't chosen what letter to put in there yet, that's a dash. It prints a little more easily than just a space. So we're going to check to see if the character we're walking over, and remember this is walking over every character in the span, whether it's horizontal or vertical, it's going to get every character in that span, because that's what we wrote last time we wrote this get point command. Well, if that character happens to be a blank, let's just record it. And we called that what? Has blank. And was it singular or plural? Let's just take a look back up here and take a look. So it was blank. So I put it as plural. That's probably okay. Has blank. So we need to want to say has blanks equals true. Or if it has a letter, and let's going to have to figure out what a letter is in here. This is going to be some code. Has letters equals true, okay? And then we're going to go ahead and just do the work like we did before. So there's really no change in the work we're doing. We're still getting this character, getting it from the box, and then writing it to the temporary string. It's just that while we're doing that, on the way by, we're catching the attributes of the characters as we're walking through them. That's just a more efficient way to do it, and it kind of makes sense. While you're getting the string, you know, it's going to return both the actual string contents and some attributes about that string. It's a convenient way, and that's a pretty common way for queries to work like this. You know, you're going to ask for something, and then by the way, it's going to also tell you, oh, you know, while we were doing that action, we observed these other sort of interesting attributes. So that's kind of the nature of what we're doing here with this call. And the last thing to do here is this query here. Well, remember how we did this before? We had some other code in here that looked for letters. I think it's right up here, in fact. Is letter we wrote. So this was a query we wrote. And remember, this is all part of what class? I'm just scrolling up here. This is all part of the grid, right? So we already wrote a letter, a function, a routine called isLetter, and it took in a certain point. This code here, we could also factor that out into a separate routine, but I think we'll just copy it for now. That's fine. So we're going to put that in right in here, right? So if you follow what I'm doing, we're going to say, look, if C is a letter, so if it's a blank, then put the blanks equals true. Otherwise, else, if C is bigger than or equal to A and less than or equal to C, then do this other thing. And we know that everything's capital letters. We converted it all to uppercase already, and then we get the letters. Okay, so that's going to set us up for the get string doing kind of the hard work, right? Now we just have to do sort of the easier work. And one thing that we have to do, or that we can already see that we want to do, is not just to have these Booleans, but let's also offer just a couple of lightweight functions here. Remember, there's three cases we were thinking of. One is when it's completely empty. It is empty. This is going to be const. What's the empty case going to be? Well, it's going to have blanks, right? And it has no letters. So that looks like that. Is that right? If we found some blanks, but no letters. Okay, the next case is going to be, and let's leave it, well, because we're not quite sure what we're going to do yet. The next case is going to be, is it partial? And the next one is going to be full. So this is the challenge for you right now. Go ahead and write these two routines. Write the logic in these two routines to see what you write in there. What does partial mean? What does it mean for a grid to be partial? Well, it means it has both some letters already filled in and some blanks still to go, right? So that's pretty much just going to be the logic. Has blanks and has letters. Okay. Then the last one's going to be is full. What's that going to be? Well, that means it has no blanks and it has letters. Okay. So look at those and see if those look right. Empty is that's all blank. Partial is it's got blanks and letters mixed. And then full is that it has only letters. Okay, so now let's go to where we use getString, because we've added, remember we changed the code now to add this. And just to show you, this won't compile because where we call getString doesn't expect this attribute. So let's just demonstrate that so you can see. Let's compile it, and you'll see it'll complain that, right. Actually, this is a different error. Okay, let me fix that one. So 172 is here. Oh, yes. Okay, so that was a typo. I need to return. This is why it's good to always fix everything in the compiler warnings. These are just warnings, but they're really errors. No return statements. So I didn't return things. Okay, let's go back and recompile that. And you're going to see, right, so now we're at line 330, no matching function call to getString const span. So it's trying to call this thing. Let's go back and look where we're calling getString. So here's one example where we call it. This is back in the print spans routine. We don't really care that much about this routine. This was just a diagnostic routine. What we can do then is we can define one of these attributes. This is going to be the object because getString requires one, and then we're going to pass it in like this. That's all you have to do. The getString, we don't have to use the attributes if we don't want to. So the getString that we defined added this argument, which is a reference to attributes. So we just have to pass in an attributes that this can write to. It requires that. So that's the first one. And the second one is the one that we're interested in. It's the one that we're writing in this loop. We're starting to develop this loop routine. And that one, we want to do like the same thing, attribute. But this time, we want to do something with it. Now we want to think about it. Because we've written these 3 routines up here. Actually, let's put the empty. I kind of like having the empty first. Empty, partial, done. That's kind of a nice way to order it. That's where we've ordered it up in the attribute class. So let's just do it now. This is another good challenge. Use the attribute now. Write some code in here that's going to say if something. And what I want you to do is to put in the code that will add the slot to the right one, to the right vector. We got these 3 vectors of slots we're trying to classify, right? Every span, there's going to be one slot for corresponding with every span. And we're going to make up the slot. So you have to use the constructor for the slot, but you have to decide which of these it is. So write that code in here. Okay, and that code is going to look like this. We're going to say, since we've already designed the attribute class to support this, it should be pretty easy. It's basically is empty. We already have that function call, right? If you go back to the attribute class, here it is. We wrote that, is empty. So the getString is sort of setting these two. These are very different. So just so you understand, these 2 things down here are actual members of the attribute class. Those are data objects. And the getString class, the getString function, is setting these based on what it's seeing in the string. These are just functions, and they use this data to return something more meaningful to the user of the attribute class. So that's what we're after right now. So if we get to the getString use, this use here down in the, remember this is the loop class that we're writing. This is all part of the new solver, just to double check. Here's the bottom of it, here's the top of that class. Sorry, we're mixed up here. Here's the top of the solver class right here. So it's not very big yet. And here's the loop function. So we're going to check if the attribute is empty. And what do we want to do? We want to say empty. Oh, you know what? We don't want to say spans. Those are really slots. Yeah. So we're going to say empty slots, push back, and then what? It's going to be the constructor of a slot. And what does a slot take? It just takes the span. That's it. So that's it. And slots, remember, is just the objects. We're not doing with pointers, so you don't have to do anything. There's no new here on the stack. I mean, there's no new here on the heap. You just allocate one right here directly, and it pushes it back onto this list. And then we're going to do the same thing. So we're going to say else if, and we're going to just repeat that. Attribute is partial, right? It's going to be partial slots, push back the slot, and then the last one will be else if it's full. Oh, so I think full is a better name than done. Full. Okay. So let's put in full here. Okay. Now we have those three lists. Let's just do something here. Let's just say we're going to actually use the counts of these. So let's make up some variables. Num empty equals empty slots size. Let's do that for the 3. Oops, that's going to be 5. Okay, so num empty is the empty slot size. Num partial is the partial slot size. Num full is the full slot size. And let's print those out. Okay. There's still more we want to do here. We want to... Oh, I made a mistake here. Can you see my mistake? Ha, mini challenge. What bug did I make here? We're looping over all the spans, adding to these various lists, right? And then I wanted to print out the size of the list. Well, look, I put all this stuff in the wrong level, right? This is all supposed to be after this. Right. We're supposed to be looping over all the spans inside here. And for each span, we see what kind of span it is. We add to the right list, and then we at the end of that, we print it all out. And then we still have this one that we want to do yet. But let's go ahead and compile this and see if we can get this to compile. Okay, let's go ahead and run that, and we'll see what it prints. And here we go. It's our normal dog cat, as before. And it's printing now all of the spans, right, including the strings that come out of them. And then it is counting them. And look, it's saying there's 6 empty, 6 partial, and 6 full. Now, why does that matter? Because we don't care about the empty ones. We're not going to try to go solve these empty ones. We don't care about the full ones. They're already done, like cat. What we care about solving are the partial ones. So we want to pick one of these slots. And there's actually a whole advanced module I'll do on the policy engine, which slot you pick to work on. It's actually extremely important, but for this small example, it doesn't matter. We can just pick the first slot. So what we're going to do is we're going to say if the number of empty slots, let me see, let's do, if the number of partial slots is 0, and the number of empty is 0, we're done. That's actually a solution. It means everything is full. It means we've filled every slot. So once we start recursing, we're not going to hit this now, but later when we start recursing, we're going to actually hit this thing. We're going to hit a solution, and then we'll have to deal with that. So there's a fix here. We're going to have to say, what do we do? What do we do here? We're going to print the solution. We're going to say, great, we found a solution, and then what? So we'll figure that out later. So then let's just make sure that there is a partial to work on. Let's assert that non-partial is greater than 0, okay? Just to make sure that we're on firm ground for doing this, which is to say CommitSlot. And we're going to pick the slot that is the partial slots 0. We're just going to pick the first slot. And we're going to come up with another routine here called CommitSlot. That's going to take, we can take it a const slot, that's okay. Slot. So what this is going to do is going to say commit slot. And then what we want to do is we want to print it. We have a problem. We haven't written, I don't think we've written a print for this function yet. Let's try to compile it and we'll see how that fails. It probably will fail on the print with a horrible message. The usual horrible, right, no match for operator, less than for slot. Right, so let's go do that little homework. Okay, that'll be a good challenge for you. Let's go back to the slot. Write something here that does the print routine so we can just print the slot nice and easy. Go ahead and do that, and then you can come back up. So a hint for that is you can just steal that code. Operator, just go up here to one of these, like here's a span, for instance. So take the code from the span, just steal it, and then just paste it in here and change the span to slot, right? That's all we have to change for that one. Go back up to the span and then grab the code for the actual printing. And then go back to the span. And now you can, oh no, the slot, and now you can put it here. So that's just the template because you want to get all this all this nonsense about the O streams and all this stuff. You want to just have that already done from another example. So here's a slot. And now what do we want to print for the slot? Well, I think what we could do is just, obviously all we have right now is the span. Let's just print the span. So let's just print the span. Let's just leave it at that right now. That's pretty easy. And let's not do a line feed. We'll let the caller of this do the line feed. So let's take a quick break here and see if we've got this thing compiling. Okay, so let's check this one error. 351 for me is right here. Oh, yes. So it's not just a span, right? Whose span is it? This is just, it can't just be span. It is this slot span. So it's s.span. Because this function is actually a function outside the class. We're not in the class right now. We're sitting outside of it. This is the way the operator overloading works. This has to sit outside. So hopefully that's not too big a glitch for you. Let's see if that compiles. And it does. And let's run it. And now it's going to say committing slot down here. Look at that. Committing slot. The slot we're going to commit is the one starting at 0, 0, and it's the 4-length vertical one. So this is going to be the one that's going to be D blank, blank, blank. And you know what? It'd be really nice to print that right here. When we print the slot, it'd be nice for it to know what its pattern is. So that's going to be the next challenge for you. Go back to the slot. Let's add in here. I want to add a span, and I want to have also a pattern, let's call it. So this is the challenge for you, is to change the constructor for slot so that it includes the pattern, and then print it also. Okay, so there's a few things to do for that. The first is the constructor has to change. You have to take in a string now. And like all these things, you can take a const string p for pattern, and then you're going to copy it into pattern like that. That's a good design style. In fact, yeah, I'm kind of not being consistent, but you could also do that here too. This could be a const span here. It doesn't really matter. Okay, the next thing to do is when you print this thing, let's print the span, and then let's also print maybe a space, and then let's print the pattern, right? Oh, maybe we'll print it a little bit nicely with, we can print a little, how about this? Actually, we can put that in here. Right, so let's put a single quote, print the pattern, and then a single quote again. Okay, that'll make it look a little more nice. And then now the problem is when we build the slot, let's see what happens, what we have to do. Now, remember the constructor for the slot, now we've changed it. It takes a span and it takes a pattern. We're making the slot know a little bit more about itself. Now it knows where it is in the grid, and it also knows what the characteristics of those boxes are, what the current state of those boxes in the grid. So let's look at where we make the slot. This is not going to compile anymore because we're not giving it the pattern. So this is another little mini challenge. What's the pattern? And it's actually pretty easy. It's just right here. It's this temp. Okay. That should result when we run it again in it telling us more about which slot it's committing. Let's see if that works. And it does not compile. Oh, right. So I did the same mistake I made before, where it's not just pattern here, it's actually slots pattern. I keep making that mistake. I'm used to having things part of the class, but here you have to get it through the object because this is outside the class. That's all just because of the way the print overloading works. So don't worry too much about that. Okay, so here we go. So let's run that, and here we are. And you can see now it's telling us, now this is great. Now it's saying we're going to commit this slot, and it's going to be D blank, blank, blank. So the last thing we have to do for this module now is to show what are the possible choices for that. So we wrote a routine, in this routine called CommitSlot. Let's say possible word choices for this slot are, God, my typing is atrocious. Okay, so and we're going to go ahead and do that, but what is that going to be now? And let's look back. If you remember in the library, we wrote this thing called find word. And what we did for find word is we gave it the pattern, and it found all the answers. It found this word list, and then it just printed it in here. We really don't want the find word to be doing this printing. We really want find word just to give us back a pointer to the list of words directly, because we want to call it and use it ourselves. We don't want to just print stuff out. We want to actually take those words and do things with them. So let's change this function find word. And let's see, we don't even use it anywhere anymore. We just used it for debugging. So nobody's calling this, so we can change it. And we're going to have it return directly the const word pointer. So if it finds that it has words, it's going to just return it. And it's going to return what? This thing. Okay. This iteration here, we're going to just take it away. We're going to go save that for a second. We'll just save it here, and we'll have to do the other case here. Else, if you don't find it, what do we have to return? Well, there's a special kind of thing for pointers in C++. It's spelled different ways. You can spell it null. That's fine. That actually compiles to the right thing. It's just different ways of spelling 0. Another way to do this is to say null pointer. Some people like that. I'm just an old-fashioned guy. I like this null. It also kind of stands out nicely. The compilers today treat this just the same as null pointer, so there's no loss of generality in the compiler when you use this spelling anymore. There used to be, but now it's all tuned up. So this is what. So find word. We should probably put a comment here. Returns null if can't find any matches to the pattern, to the given pattern. Okay. So now let's take this stuff and let's go back to that CommitSlot routine down here. And we're going to put it in here, right? We're going to say const words pointer, let's call it like words is fine, equals, and what? It's going to be find word, but it's going to be, first of all, it's going to be the library's find word, right? And then what does find word take? It takes that string pattern. Now, what did we do? We just put the pattern into the slot. That was really great. So we can just say slot.pattern. So that should be all the information we need. And now we can say if words, else, if we had a match, we'll do this stuff. We'll print something. Otherwise, we can print no matches to pattern. Something like that, right? And here we'll print the actual matches to the pattern. Now it's no longer an iterator. We're not doing that anymore. We can put in words in here. Let's see if that'll compile. This is a pointer to a list of words. And let's see how it will do. This is a bit of a quiz. Let's see how it will do with this. All right, ready? Let's compile this. And right. So this is a subtlety, and this is sort of the thing that C++ gets a bad rap for. You have to be a little careful about pointers to things and actual things. This format of a for loop really wants the actual vector here. It really wants to have something that's the actual vector, which in C++ case, since this is a pointer, you get with that star, right? I didn't even look at this error, but that's probably what it is. Let's see if that is the error that it complained about. Okay, so now I have another error though back up here in line 83. It has to do with the returning of the iterator. And these iterators are always a pain. I have to always look at the documentation to remember if it's it dot or it arrow. They overload the arrow to let you get at the iterator. Let's go back and look at that, and I'll try to do that a little bit more slowly. 83, return iterator second. Yeah, so what this will actually give you is the actual vector itself. So what we want is actually the address of that thing. So let me do a quick little review of what we've got for that, because it's kind of confusing. Remember we had taken the words and we'd made them objects on the heap. We allocated them with new, and there's this master list of words. And then we have this big pattern hash table, which is kind of complicated, but every pattern like this D blank 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 resolves itself into a vector of these words, and it will point to just the words that are part of that pattern. This will be the word, date, and this is going to be data, and so forth. What we're doing here in the code is we're trying to pass back from find word a pointer to this vector. So when we go into the find word routine here, this has to be the address of the actual vector that's there. Right, so I see an error here. This is supposed to be it's supposed to be a pointer to the vector of words, not a pointer to a single word. Right, so let's see if that clears things up when we compile it. And we're closer, so 83 now. Okay, so now we need to take the address of that, I think, because this is going to be the actual words vector itself. We want to return a pointer to that words vector. So let's see if that does it. And it does, and we run it. And look, this is pretty much it. So now we're saying, here's the analysis of the grid. We have all these different spans. We're going to go ahead and pick the very first partial span, which happens to be the one at 0, 0 that goes down length 4. It's vertical. It's D blank, blank, blank. So it's this one here. And here are all the possible word choices that we found in our library. So we're prepared for the next lecture when we're going to commit these words. We're going to just do a big loop over these words, and we're going to start writing them into the grid. And then we're going to repeat this loop. So this is pretty much the whole essence of the algorithm here, is that you take a word, you write it to the grid, and then you call again and you see what words will work on the next slot that's partially done. And finally, you'll get some of these lists. A lot of times you'll have these lists that'll be empty. And so we'll do the recursion in the next module. I think we're only 1 or 2 modules from finishing the entire course. So we'll see you there.